Hey guys, this is Brendan from Markforged 3D printers. Over here we have our Metal X solution. It is our end-to-end metal 3D printing technology, including the printer itself. We're currently printing in 17.4 pH stainless steel. This is an impeller that we're printing. That part itself is our green part, printing with the metal powder itself with a wax polymer binder. That's how we're keeping the material in its raw form in filament. That part, once it's done being printed, is going to get put right into the wash station, which we have right next to it. The wash is going to use a chemical called Opteon Scion, which is a solvent-based material or a solvent-based chemical that is similar to an industrial degreaser. This is going to remove just about 95% of our polymer, so you're left with a very brittle metal part. Once that part's done washing, this is an example of one of the parts we actually printed just yesterday. That's 17.4 stainless steel in the green state pre-wash. Once the part's been washed, it's called the brown state. We're going to put that right into our sintering furnace. The furnace is going to shrink that part back down after burning out the remainder of the polymer. So you're left with a part that is net shaped to your design, layer height of 50 microns or 2,000ths of an inch, with XY dimensional accuracy of plus or minus 5,000ths of an inch. Very accurate, very functional metal printed parts that are a one-for-one replacement of their traditional material. So these are a couple examples of wrenches that we printed on the Metal X. These are 12mm wrenches out of 17.4 stainless steel. We have a couple awesome composite and metal hybrid tools over this way. And somebody stole my carbon fiber tool. So this is an example of a CMM fixture printed on our composite technology. Using heat set inserts and inserted springs. So it's a functional part, maintaining structural integrity and accuracy. So as the CMM tests the casted part, we can get accurate readings. These are a couple examples of our hybrid tooling, where the actual parts that experience high wear are actually printed out of H13 tool steel, and the actual bodies of the parts, which were traditionally machined out of aluminum, we've actually replaced using our carbon fiber, or our onyx reinforced with continuous strand filaments of carbon fiber, making these parts significantly cheaper, using about $235 of material and only taking 4 days to print both the metal and the composites, when this was a 1 week to 2 week machine part lead time.
Very nice.
So this is a custom sensor bracket utilized on end-of-arm robotics tools and in sensor systems, using our technology as very rigid materials with tight dimensional accuracy, so that the printed parts themselves are actually going to maintain the structural integrity and be able to film continuously within the robot.
Very nice.
Thanks for stopping by.